Welcome to Unit 9-6. This one's called Solving a System of Linear Inequalities. We've spent quite a deal of time talking about a system of equations. Well, we know the difference between equations and inequalities. Equations have that equal sign, makes things nice and friendly. Something is what it is, and that's it. An inequality, not so precise. It could be greater than, or less than, or somewhere in between there, yeah? All right. First, our math career, a college professor. College professor, the pay starts off a little low there from what we've seen in other careers, but can jump pretty rapidly once you get established. Of course, you can imagine the math and stuff that you're going to need. Of course, this is your gateway class to all of these things, and right here is the math we would be looking at, building upon what you've learned all this year and going forward. All right. Good job, I think. Today we will learn to graph and solve a system of linear inequalities in two variables. So our vocabulary for today. A system of linear inequalities is a set of two or more linear inequalities containing two or more variables. So in this case, notice, here's an example. Y is strictly greater than negative x plus 4. Y is greater than or equal to x plus 1. Now we've seen these. We saw these in a previous unit where we talked about graphing these independently. Well, here we're going to be looking at them together. And basically what I'm going to encourage you to do is look at them one at a time until the very end of our graphing or solving, looking at it, and see what happens. Okay? So notice here's two inequalities. All right, a little bit more vocabulary here. The solutions of a system of linear inequalities consist of all the ordered pairs that satisfy all the linear inequalities in the system. We're just going to be looking at two. Could there be more? Yeah, there could be more. But we're going to restrict our lessons just to two. All right, so let's take a look at this. In each of the following, tell if the ordered pairs is a solution for the system of inequalities. Just on your own there, just give us a thumbs up or a thumbs down whether this ordered pair is going to solve the system. Let's see, 2, 1. So I'll plug a 1 in here and a 2 here for x. I'm going to end up with, let's go ahead and walk through the first one here. Let's see what happens. So if I do the top one here, I'm going to get a 1. What we're saying is 1 is strictly less than negative 2, the opposite of 2, plus 4. Let's see, 4, negative 2, 1 is less than 2. This looks like it works to me. Okay, what about this one? I'm going to put a 1 here is less than or equal to 1 plus, do I say 1? No, it should be 2, right? 2 plus 1. Let's see, 1 is less than or equal to 3. Looks to me like that works too. It works for both, so what do we get? Well, we give that a thumbs up. All right, thumbs up, it works. How about this one? Go ahead and plug those in. And if you need to, press pause, work it out real quick, and let's see if you're right. Did you say, no, thumbs down on that one. Good, thumbs down on that guy. How about this one? Plug a 0 in there for y and a 2 in there for the x. Remember, if it fails on one, it's going to fail on both of them. So let's see, it looks to me like this is 2 times 2, and this is a 0. Thumbs down. Very good. Thumbs down. All right. To show all the solutions of a system of linear inequalities, we're going to need to graph because there's no way to algebraically show all solutions. So, the solutions of the system are represented by overlapping shaded regions. And what does that mean? Well, you recall from a previous time together that when we graph this, this would give us a shading, all y values less than or equal to this line. Remember, we would draw a line, or we would see, just by inspection, we could see a line that was solid, and it was all the y values shaded below the line. This one here is, of course, shaded below also, but this one's not going to be a solid line, it's going to be a dashed or broken line. So let's take a look. So if we were to graph this line right here, and we're going to do our shading, notice that it's less than or equal to, and so we shade everything below it, nice solid line because of this line underneath, correct? So in other words, this line is part of the solution. All the points on this line are involved in the solution. How about this one? Now this one gives us a dashed line because the line is not part of the solution. So after you've gotten through drawing or looking at this, what we should do is pretend it's not there. Just ignore that one and let's just focus on the second one. Let's go ahead and graph that one. Okay, and then shade below that one. And notice now where these two shaded regions overlap each other. Right here is where they overlap. And anything in the overlapping section will solve both inequalities. So any point that you choose in here, if you plug it in here and here, will indeed work. Guaranteed. So if you take a point like this, you put it here, well, this is a solution for one of the systems, one of the equations in the system. I should say inequality. Sorry, I misspoke. One of the inequalities in the system. This point here will be a solution for the other one. But anything inside this region here is going to solve neither, right? Because it's not in either one of them. And what's our last choice then? Well, our last one here is anything in the shaded overlapping region is going to solve both. It's going to solve the system. All right, so 3, -5 is just one solution for both inequalities, but of course there's lots of solutions here. In that shaded region, you can pick anything you want. Well, let's just pick one and make sure it works. Okay, so plug that in. Sure enough, 3, -5, and plug in 3, -5, and there it is. So it does work for both. You can also see that graphically by looking at where it crosses. All right. Under a system of equations, two lines with the same slope and different y-intercepts are parallel and have no points in common, and we said there was no solution. Remember this in the previous lesson where we had two parallel lines and there was no solution. But now if we're talking about inequalities, inequalities can be a little bit different because if they have the same slope and different y-intercepts, they're parallel. They may have no points in common, and they may. So let's take a look. This one here is a solid line shading below the line. This here is a solid line shading above, and sure enough, they have nothing in common. But what happens if one of these lines was actually to be shaded below? Well, let's take a look. So, under what circumstance would the two inequalities with parallel boundary lines may have many points in common? That would be if you reverse that inequality there, the one here that says shade above. Well, what if it was reversed and it was shading below? So it would depend on what side of the boundary we were shading. If the second equation becomes less than, we now have two large overlapping areas, just like this. So notice what we did here. We switched this inequality, and now look what happens. Now we've got large overlapping areas. So if we looked at a point, this point here would solve this guy. This point out here would solve neither of them, but this one would solve both simultaneously. This one and this one. Yes? Okay, good. All right, that's it for Unit 9-6. If you want to see some more instruction here, go ahead and take a look here. Dr. Berger and his team will help you out. Digital score practice is at the same site, and you can get some instant feedback. All right then, it's been fun.